Right, okay. Hi, I'm Phil, and I'm going to give you a bit of an introduction to the high altitude ballooning. How many of you have actually tracked one of these balloons on 77s? Okay, quite a few. So on the title slide there, you've obviously got a balloon. Okay, that's not meant to happen. Right, there we go. So the idea behind ballooning basically is the exploration of space. So space is defined as 100 kilometers. Actually, the atmosphere starts to... Is the audio okay?
Hand mic for now.
Yeah, sure.
I think you. Yeah, the battery's.
Right, okay. Is that a bit better? Yep. Okay. Okay, right. So, starting again. So, space is defined as 100 kilometers, barrier there, but the atmosphere actually starts to tail off towards about 20 or 30 kilometers. So, conditions are reasonably similar at the kind of altitudes that we do, but the balloons, people call them space balloons and stuff, they're not really space balloons. The amateur record, as you can see, is just over 44 kilometers, so not actually that close, but you still get pretty amazing photos, like this one on the left here from one of the amateur projects. And most people go in it for the photos, but there's also a technical challenge as well. So on the bottom left, this is one of the university teams on the launch site trying to get their payload to work. And it's obviously vital that your payload works, because you only have one shot at it with the balloon and helium and stuff. And also if your tracker works, doesn't work, you're not going to get it back. Okay, so the basics of these HABs, is that now working?
Yep, should be.
Swap back.
There we go.
Okay, is that good? Right. Okay, so the basics of these balloons is you've got the balloon at the top, most often made out of latex, and that has the lifting gas. That's got the hydrogen or the helium. You've got the parachute for when that balloon bursts and it comes back down. You have the instrument, so your sensors, your camera, whatever you want to take up there, and then a GPS tracker, some way of getting it back afterwards. So obviously from a technically simple point of view, you just want to know where it is so you can get the data back from it, if you have no way of getting the data back real time. So the sensors that these quite often have in, the first one you'll see most often is temperature, because temperature sensor is very cheap. You can see that it gets really quite cold up there. It can go down to -40 out of the sunlight. Payload tends to go down to about -20 during the day. So it really is quite cold. And of course the pressure tails off completely. It's about 1% atmosphere at 25 kilometers. So that actually affects the temperature a bit, because you've got no convection to take away the heat, which is why the payload warms up so much during the day. And then most people put in cameras, so a GoPro to catch the video, or the Canon Hack development kit can be set to take on Canon cameras a picture every 30 seconds or so, which works quite well for taking interval photos. Some people do send up digital SLRs, but then you've got to have faith in your tracking system to get it back. So the tracking of these things. So you've got a payload with your camera, a couple of sensors on. You send it up, but you want to be able to get it back afterwards. And there's the most obvious way to do it seems to be with a GSM modem or a phone that texts you back the coordinates. The main issue with this is that mobile phone base stations are all pointed out horizontally, so they have no gain upwards. And so once you're up above maybe 4 or 5 kilometers, you don't get any signal anymore. You've got line of sight to the phone tower, but there's no signal up there. So it goes black for most of the flight. Then when it comes down on the parachute, it's got a few minutes to come back down through the coverage, and then it might land in a ditch, but there's no coverage at all. So that tends to be a bit iffy. We've found that it tends to be about 50-50 in the community as to whether they work or not. Satellite modem is another way to do it. Obviously that means it should work for the whole flight. The satellite doesn't really care if you're at 30 kilometers or 0. But they tend to be very expensive, reasonably heavy, and also if your payload lands upside down, it's not going to work very well. So the other way of doing it is radio tracking. So APRS seems to be quite an obvious way to do it. The infrastructure is already there with digipeaters. The gain on digipeaters is usually quite low, just a dipole, so actually they work very well at an upwards angle. And this is used quite a lot around the world in the States and stuff for balloon tracking. It has the disadvantage that you can only send a packet every 5 or 10 minutes. Because when you're up there, you're covering several digipeaters. You're actually using up quite a lot of the channel bandwidth in a way. So people will get quite annoyed if you send a packet more than every 5 minutes or so. And the obvious barrier to this in the UK is we're not allowed amateur radio airborne, so that's out the window for us. So the other way to do it is custom RF. So a couple of the guys in the community a few years ago came up with using ISM modules. These are 10 milliwatt modules, like your car key fob. They're allowed airborne, and so we can use that 10 milliwatts. Quite a lot of these have built-in data modes, about 1.2 kilobits or so, but the signal-to-noise margin doesn't allow you to use that with the hundreds of kilometers of path loss. So a couple of the guys came up with, well, why don't we just shift the carrier frequency? It's about 50 baud, encode it with 8-bit ASCII, and you get radio teletype, which means we can use FLDigi and an SSB receiver to decode it. So from a payload in FLDigi, you see the RTTY tones coming in, and then you've got the GPS coordinates, the altitude, and the sensor statuses coming in. And then there's a CRC16 checksum on the end. So the bar at the top goes green when the last sentence was correctly checksummed. And the great thing about this is the implementation. You can get the ISM modules from Radiometrics that are designed for FM data, and we just level shift the input with digital data, and it shifts the frequency, and then connect an antenna to the end, and you've got a transmitter. Easily done with a microcontroller, Arduino. So the serial string that was sent there, there's an example at the top there, which actually is missing one of the fields. So $$ gives the start of the serial, so that's what the software looks for to start the checksum. Call sign, there will be a telemetry counter for the number of the telemetry string. Then you've got time, GPS coordinates, altitude, and normally number of satellites, so you can tell whether it's got a fix or not and how much of a fix it's got. And the software then integrates with a mapping server that's been set up and a database server, so that you get on the bottom left here, it gets put on a map. Green lines get drawn to the person who's tracking, who received that telemetry string, so that can be multiple people. And you get a nice little status display of what's going on. And a couple of guys from Cambridge Uni have put in some prediction code, which predicts where it's going to be based on the Met Office wind data. And then because the database is open, there's also guys which have put together, one guy put together this graphing page where you can look at the telemetry from the database, pick any payload that's in the database, what telemetry, what date range, and you can look at the graphs, which is quite interesting. And allows a lot of analysis of data, and people make their own tracking pages and stuff like that. So what I'm going to demonstrate here is SSDV. This was developed by a guy living in Northern Ireland, and he wanted to be able to send pictures down live. Now he did this with a microcontroller and a camera that spat out JPEG encoded images. So he split that into blocks, did Reed-Solomon error correction on it, and then sent it out as 8-bit radio teletype. He then put some code into FLDigi that decodes that, checks a checksum, and then puts it together as parts of a JPEG. So as the JPEG comes in, you end up with it filling up block by block. This can be quite slow at 50 boards, so it's normally used at 300, or I've got this set up at 600 board. And then the great thing is these blocks, the valid blocks, are then all sent to a server. So, and the server stitches all the valid blocks together. So even if you're only receiving a third, if there's 4 other people receiving it, you can probably put together a complete image as between you all, and it shows up on the website live. Right, so let's see if we can get this to work. So what I've got here is there's a Raspberry Pi in here with one of the radiometrics modules, and the Raspberry Pi's serial output keys the radiometrics module and sends JPEG data over that. There's a Raspberry Pi camera here that will take the photo. I haven't got this linked up with the GPS tracker at the moment, so I have to select the mode manually for this demo. Right, tried this a few minutes ago, but let's just reboot Pi. So for the GPS tracker side of things, you can really make them quite small. So this is a GPS tracker board that I've used in the past, and it's just got GPS chip, an Arduino chip on it, and then it's got a 434 megahertz ISM module on there, and that sends back the fizzle telemetry you saw. That's the call sign that I've used for this board. And then I've put it in this, which is 1/2 of the polystyrene box with a couple of batteries, and that tracked for about 8 hours or so off those batteries. And the plan is that this would then key one of its GPIO outputs at an altitude trigger, because this is also set up with a 3G dongle to stream through BATC.TV. So it will do that for when it has 3G coverage for the first 1,000 meters or so, and then switch back to the radio teletype for the rest of it. Yes, this is working. Okay. So you can see that there. That's the carrier signal from the NTX2 transmitter module. And then this is the customized version of FLDigi that has the code. So that's just one carrier coming in. So if I do, this will then be run automatically at altitude. And once that's taken a picture, and then there we go. So that's the 600 baud radio teletype coming in. And you can see the bar's green. It's the checksums working. And then there's a picture coming in of the front row here. So that's been, this box has, when it's straightened out, quarter wave antenna on the bottom with a simple ground plane, which works quite well for this. It's pretty good with omnidirectional, and that tends to work to a couple of 100 kilometers. So while I was messing around with the antenna there, you can see we've missed a block, so it's just left it out and carried on with the rest of the image. Yeah.
How long to fill up the picture?
How long to fill up the image? That one's probably a couple of minutes. I haven't timed this image size. So obviously you can go for really big, really high definition images, which take several minutes, maybe 10, 20 minutes, or you can go for really small ones and get maybe a couple of minutes coming through. So you can strike a balance with that. Right, so quickly back. Presentation. I'll just leave it at that. Right, so a couple of other things that people are trying in the balloon community. The big one at the moment is there's a guy, Leo Bodnar, who's doing these floating party balloons, which are going up across Russia.
Launches from the UK.
Launches from the UK. He actually launched them from Silverstone racetrack, I think. And this is one of his. So he's got a foil party balloon, and then you can just about see the payload there with 2 little solar panels and a quarter-wave antenna on it. And he's got a LiPo battery. It charges the LiPo during the day, goes into sleep mode at night when it doesn't have enough voltage, wakes back up in the morning. And these have survived for days because they go up, and these balloons don't expand. So it goes up until the balloon fills up, at which point it holds it there. The balloon stretches a little bit and stays taut, and it stays up at about 8 or 9 kilometers and just goes with the wind. And they tend to... Previous attempts have ruptured after a couple of days, but somehow this guy, with using really light payloads, this is 10.7 grams, the whole tracker battery solar panels at the bottom. And these have survived for 8 or 9 days, I think. Yeah.
One over Russia at the moment.
I think there's a couple over Russia. He's got one with APRS, which is switched on automatically as it's left the UK. Yeah, with geofencing. So there's that. I've had to go try and take some photos of balloons from the ground when they're up at 30 kilometers, which has been quite interesting trying to spot them. There's some guys trying to take photos from the balloon, but properly stabilizing it and shielding out the light from the ground so they can get a good space picture from above the atmosphere, like a cheap Hubble, if you will. And then there's, inspired by these party balloon floaters, there's a guy who's offered some money for an Arctic Circle challenge. So the first person to float any balloon of any kind into the Arctic Circle and be able to track it as it goes over the Arctic Circle. There's some money up for that challenge, but nobody's quite worked out how to do it yet. So, any questions? Yep.
We've done a couple of launches.
Yeah.
We actually did live 2.4 gig video download. So that was quite
Oh, right.
successful.
Okay.
Following it with this. But also, the problem we ran into was A, insurance, which is a big problem. B, the price of premium.
Yeah.
And C, the reluctance to give me hydrogen. I wonder how you've got round to this. That's a big point. Yeah.
Okay, so the first point was insurance. And with insurance, there's a few people looking into insurance, but it's most people for the hobby launches fly without it, and just take reasonable precautions. There's a predictor tool which is quite good at working out where the balloon's going to land. The reason I'm not flying one today is because it said the best I could do was 10 miles offshore, which I really wanted the stuff back. For commercial launches, you can get insurance, but it's on the cost of several £1,000s, which is slightly out of the range for a hobbyist. So there are some guys looking into it. Most people just try and take precautions, not landing it in cities, not landing it on airports, that kind of thing. And you have to apply for launch permission from the air authorities, and they'll give you a launch permission on a certain date to launch the balloon, and so that aircraft are aware of it. The second point, which links into the third, was the price of helium. So yes, helium is very expensive. To do a big balloon launch, it costs about £100, £200 of helium. The cheap way to do it is to go for hydrogen, which obviously carries risks. There are lots of people in the community using hydrogen, but and just taking precautions, no smoking near the balloon. You have to get a special regulator for it, and as long as you do that, it's pretty safe, because the balloon's going to go up there. If you do the up burst and then down, there's not going to be any hydrogen when it comes back down. So once you've got it up and away, the risk is minimal from that point. For the floats, most people still use helium because there's a chance of it puncturing slowly and coming back down still inflated. But yes, hydrogen people do use to get around the price problem, and with reasonable precautions it can be quite safe.
Do you have any problem
Getting hold of?
hydrogen?
No.
I was struggling with gas suppliers and struggled with supply.
Oh right, okay. I haven't got any myself, but I'm aware of people getting it quite easily from Bock, I think. Yeah. Any other questions?
Is there any future in tethered, very lightweight fishing lines like tethered balloons that you wouldn't then lose it, you could actually turn it in?
So tethered balloons, it tends to, you can only get so high with them. I mean, we can get a balloon quite easily up to about 35 kilometres, and some of the small ones which I've got through there will quite easily go up to about 20.
If you wanted to take photographs at a lower level for agricultural use?
Yeah, at a low level, certainly. People do use tethered balloons for that. The difficulty comes with the wind. If it's quite a windy launch site and you're just launching a balloon, you can, as long as you get it up above the trees, you can let it go, whereas with a tethered balloon, it's going to be trailing quite a bit. Yeah.
What size of balloon do the regulations start? I mean, party balloon.
The party balloon goes into a clause which we know as pico balloons, where if the entire balloon, for the duration of its flight, balloon, payload and anything connected to it, can fit within a 2-metre sphere, you don't have to apply for launch permission. So that balloon never expands, so it never gets bigger than about this. Well, it's more about this. So it stays within a 2-metre sphere. The latex balloons do expand, and actually the smallest latex balloons expand to about 1.6 or 1.7 metres. So with the payload as well, you can still be larger than 2 metres, and that's when you need the launch permission.
Okay.